area and volumes of cuboid, and we will solve some objective type questions of mensuration from the 3D objects cuboid, right? So before going ahead, let us understand what is a cube. A cube is a solid object with all its edges as equal, okay, right? With all its edges are equal, and the volume of the cube can be calculated and said as, if its age is a, then if this is the length a, this is the breadth a, and this is the height a, then L into B into H, that is volume of a cube, is a cube, right? Volume of a cube is a cube. So this is a cube, right? And for the cuboid, the LBH will be three different parameters, right? For the cuboid, if it will look like this, because its length, breadth and height are different values, right? Then in case of cuboid, the volume of the cuboid is, if this is length L, breadth B and height H, it's equal to L into B into H, right? I think you are able to get it, right? Now this is a little brief on it. And what is the surface area of a cube? Surface area of a cube is, here it's a square, because you can see side into side a square, and there are six such surfaces, so it will be 6 into a square, right? Similarly, the surface area of, this is the total surface area. Similarly, the surface area of this cuboid, right, this will be equal to L into B here and L into B here, two times, front and back. So we can say L into B into the bottom and L into B into the top, right? This one, not front and back. Front and back will be L into H, right? I hope you understand. So it will be L into B two times, L into H two times, that's why 2 taken as common, and B into H two times. So this is the total surface area of a cuboid. So quickly we have seen it. Now coming to the questions directly. What are the questions? On a particular day, the rainfall recorded in a terrace, okay, on a particular day, the rainfall recorded on the terrace of a building 6 meter long and 5 meter broad and 15 centimeter. So the quantity of water collected into the terrace, so that means you can see a house is there. On the house there is a boundary, and there is some tank kind of arrangement which is automatically formed, right? So this tank kind of arrangement will be in the shape of a cuboid, right? So here the water is falling into it, right? And this is a building, this is a building terrace, building terrace. Terrace means the top part of the building, where there is, suppose due to some issues, the water is not draining out, right? So that's why water is collected over here, right? And this water which is collected over here, okay, is on the terrace, and the different dimensions of this terrace is, the length of this terrace is 6 meter, because it's given that 6 meter long, right? And the breadth, this is 6 meter long, and the breadth is given as this one, as 5 meter broad, right? So breadth is 5 meter, right? And depth is only 15 centimeter. So this is 15 centimeter, this is height, right? So this is 15 centimeters. So H is 15 centimeter. So first of all, just do one thing. What? Change the dimensions of into a same, all the dimensions should be same. So this is 6 in meter, this is in meter. So convert this 15 centimeter also in meter. So it will be 15 by 100 meter, right? Isn't it? We divided it by 100 to convert centimeter into meter. Now what is the volume of, the question is that the quantity of water collected into this terrace, right? So water collected into this terrace will be equal to the volume of this cuboid, that means volume which is formed, and the volume of this cuboid we have already studied, L into B into H, right? So what we can see, water collected is the volume, right, which is equal to L into B into H. That is the volume of the cuboid. Now put up the values over here. What is the value of L? It's 6 meter. So 6 into breadth is 5 meter, 5, and height is 15 by 100 meter. So this is in meter cube, but the volume of the water would be in liter. So we're going to that. Before that, we just calculate it, right? Now 6530, 6530. So it will be 30 into 15 by 100. So 100 will be cancelled out. So this will be 15 3 45. So 5 3 15, 5 to 10, right? So it will be equal to 450. Don't go into this. 6 5 30 into 15, 450. 450 by 100 meter cube is the volume. Okay, so 450 by 100 meter cube is the volume. That means in what is the volume in liter, right? Since this is in 1 meter cube 1000 liter, right? In 1 meter cube 1000 liter. So that means 450 by 100 meter cube, that means in 1 meter cube 1000 liter of water is there, right? So we can say 100 and 100 will be cancelled out, and 4500 liter of water is accumulated. 4500 liter of water is accumulated over here. Okay, so this is the first question which we have solved. 4500. Okay, 4500 liters of water is accumulated into this terrace, right? So in this way we have solved this question, right? 4500 liters of water. So just remember one key formula, that in 1 meter cube of volume, okay, in 1 meter cube of volume, it is equal to 1000 liter, 1000 liter, right? So this relation you need to remember, then only you would be able to calculate the liters of water content into the terrace, right? So just remember it, 1 meter cube equal to 1000 liter. This is important formula. Okay, now once had jelly water bottle. Oh, no, it's not water bottle. Basically, it's a terrace. Okay, it's a building. Okay, it's a building. You can see it's a building. On the building, there is a terrace. On the terrace, water is collected over here, right? And we are going to calculate the volume of that water, which is just accumulated into the terrace. Okay, so this is the building. This is the building. Okay, and on the top there is a terrace, and due to rainwater, due to on a particular day the rainfall recorded in a terrace 6 meter long, 5 meter broad, and 15 centimeter height. That means these three dimensions are given to you, which is for applicable for a cuboid, that is L and B and H, right? We need to find the water collected into the terrace, right? So what we did, we simply calculated the volume of this terrace, that is L into B into H, right? We just put up the value, but you can see its length is in meter, breadth is in meter, but height is in centimeter. Okay, so that's why convert this centimeter into meter. So and on calculation we get 450 by 100 meter cube of volume. But how meter cube will be converted into liter? Just remember this formula. 1 meter cube is 1000 liter. Just remember it. That's why I marked it a star. 1 meter cube equal to 1000 liter. That means 450 by 100 meter cube was the volume we have calculated. So just multiply it with 1000, because 450 by 100 meter cube can be written as 450 by 100 into 1 meter cube, and 1 meter cube is equal to 1000 liter. Just substitute this value, you get the volume of the water accumulated into the terrace, which is equal to 4500 liters, right? And this is your answer, and you can solve it very easily. Now coming to the second question of objective question of this series of solid objects and mensuration. Okay, if a1, a2 and a3 denotes the area of three adjacent faces of a cuboid, then its volume. So into this question, let me write it question number 2, question number 2 for today, right? So it's given that if this is the cuboid, right, if this is the cuboid, then area of one of its face is a1, it's a1, right? Area of its another face is a2, right? This face, let's say it's a2, and the third face on the top you can see it's a3, right? Now we need to prove if a1, a2, a3 denotes the areas of three adjacent faces. Why adjacent faces? You can see this face is just attached with this face because this is the common edge, you can see, right? And a3 is attached to a1 with this edge common, right? And a3 is attached to a2 with this edge common, right? So that's why these three faces a1, a2, a3 can be said as what? Tell me. Adjacent faces. Adjacent means close to each other, adjacent, and even stick to each other, touch, right? So a1, a2, a3 are the three adjacent faces. We need to find then the volume of this cuboid can be written into the form of a1 and a2 and a3. How it can be written? So volume of a cuboid in form of a1, a2, a3 is what? That we need to calculate. Now here, let's say if this is a1, this is a2, this is a3, and if the length was L, if this breadth was B, okay, and this height was H, then A1 gives you the area of L into H, isn't it? Because this is L and this is H. So that's why this blue shaded area, okay, which is formed by the two dimensions, that is L and H, will be A1, right? Isn't it? So in place of L and H, we can write A1 as L into H, right? So I'm writing it. We need to find the volume in form of A1, A2, A3, right? This was the question. This was the objective question. So here we can write A1 as equal to L into H, isn't it? Tell me. This is L and this is H. This is simple rectangle. So this is L into H. Similarly, A2 can be written, this is A2, the second, the red marked face. This face have two dimensions. The length will be equal to B and height will be equal to H. So it will be B into H, isn't it? B into H, right? So in place of A2 we can write B into H, right? Similarly, on the top, the white one, the blank one, this one, which where we have written A3, these dimensions are formed by, here it's B, so it's also B, it's also B. So this is B, this is B. Which one? This one. This one is B, right? If this is B, and what is this? This is L, right? Because this is L, you can see here L. So this will also be equal to L. So this will be equal to L into B. A3 is, so I am writing it here, A3 equal to L into B, right? So now the volume can be written as, since the paper is less, let me shift it little downward. Yes, let me write it over here. So volume of a cuboid is L into B into H, right? So in place of L into B, we can write A3, isn't it? Or when you simply multiply A1, A2 and A3, these three figures will be multiplied, right? So before writing it, just multiply A1 into A2 into A3. When you multiply it, what you will find? L into H will be multiplied with B into H will be multiplied with L into B, right? So this will be L into H multiplied with B into H multiplied with L into B, L into B, right? So all these threes multiplied. So this will give you L square, B square and H square, right? So this will give you the volume as L square, B square and H square, right? So let me write it over here. After this, due to some crunch of paper, but I will make sure that next time the paper will be sufficient. Yeah. So when you just multiply all these together, what you will get? A1 into A2 into A3 is equal to L square, B square, H square. Hi Jara. Right? This will be equal to L square, B square, H square. And it can, LBH is the volume. You can see volume is LBH. So that's why L square, B square, H square can be written as LBH whole square, isn't it? L into B into H whole square. And L into B into H whole square can be written as volume square, right? So the volume of the cuboid, this cuboid in form of A1, A2 and A3 will be, when you take a square root of the RHS and LHS, you get the volume, that is V is equal to root over LBH whole square, that is LBH, right? And which is this LBH whole square can be written as A1, A2, A3. So this volume can be written as root over of A1, A2 and A3. So this is our answer. So volume is calculated as, so since LBH whole square is A1, A2, A3, so we can write root over of A1, A2, A3, because this is LBH whole square. So LBH whole square, you can see this is equal to A1, A2, A3. So that's why in place of LBH whole square, we can write A1, A2, A3. So this is the volume of this cuboid, right? Hi Jara, what is this material? This is mensuration. This is mensuration, and here we are solving some objective questions, and objective questions from mensuration, where we have considered some surface area and volume related questions of mensuration, right? So here we can write volume as root over of A1, A2, A3, right? So this is applicable for this question. Now what we will do, we'll simply go to some different question. Okay, what language do you speak? Hi Jara, yeah, it's English. I hope you are able to understand. I think my English is not that bad, is it? Thank you, thank you, thank you. So let us solve some more questions on mensuration. Okay, the volume of a cube. So what we have done, we did two questions. Now come to question number 3. What is question number 3? the volume of a cube whose surface area is 96 centimeter square. That means a cube is given to you. Okay, a cube is given to you, and here surface area is 96 centimeter square, and for this cube the surface area is given to you as 96 centimeter square, right? Now we need to find the volume, right? This is the question. Then what is the volume? So to calculate the volume of this, what we will find, we know, just recall the property of a cube. Here it's all its edges are equal, right? So let's say A, and surface area of a cube is, here you can see A square. This is for one surface, so this will be coming 6 times. So surface area of a cube is 6 times A square, where A is the edge of the cube, right? Now it's given it's equal to 96, so just equate it with 96. Then what you will get, the value of A square is coming as 96 by 6, right? So this will give you 6 1 16, right? And when you take the square root in both the sides, you will get the value of A as equal to 4 centimeter, right? So this is the age of the cube which is calculated. Now the volume of such cube is equal to 4, is equal to side cube, that is A cube, right? A cube. So that is equal to 4 into 4 into 4, which is equal to 64 centimeter cube. So in this way we have calculated. Now coming to question number 4. What is question number 4 for today's objective session? If each edge of a cube of volume V is doubled. So if this is a cube and volume of this cube is, let's say, V. If each edge of a cube of volume V is double, so let's say the edge is A, right? L, B, H all are same, right? Then volume of this cube is A into A into A, which is A cube. Now it's given into the question that edge is doubled. That means the new edge will be 2 into A, isn't it? 2 into A. Now it has been asked into the question, if each edge of a cube of volume V is double, then the volume of the new cube, right? Then a new cube will be formed with a bigger edge, right? With a bigger edge. And here you can see the edge of this cube is 2A. Is 2A, 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 right? So here this new cube will be equal to volume. What's that, right? We need to write into the form of V only, right? So new volume of this cube is equal to 2A whole cube, isn't it? So this will give you 8 times 2 into 2 into 2, which is equal, because it's cube, so 8 into A cube. But A cube is V, you can see A cube is V. So that's why we can write the new volume as equal to 8 times V, isn't it? So 8V is the new volume, or the volume of the cube, which is formed by just doubling the edge of the previous cube whose volume was V, right? So 8B is the answer, right? So we can opt it. Now coming to the fifth question. Fifth question. So for the fifth question, what we will do, let us see. So fifth objective question, a 10 cubic meter clay is uniformly spread on a land of area, volume of a cuboid 12 centimeter, volume of yes, this is a good question. Let me take this. If the sum of all edges of a cube is 36 centimeter, that means sum of all edges is equal to 36 centimeter, and this is a cube. And just remember, the sum of all the edges of a cube are equal, so that's why we can write A as one of the edge, A as another edge, and A as third edge, because the only three edges are there. LBH, in place of LBH it's AAA. If the sum of all edges of a cube is 36 centimeter, so all edges is not only, you can see how much edges are there. 1 2 3 here, you can see 4 on the bottom. 1 2 3 4, 1 2 3 4, 4 here and 4 here, 8 and 4 here, 12. So sum of all edges is 36 and total such edges will be 12. So this is 12, right? So what we can do, the sum of all edges is 12, the total such edges will be 12 and sum of all edges is 36. So sum of all edges can be written as A plus 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 A. Here you can see 1 2 3 4 5 6 7 8 9 10 11 12. So all these are, this is one edge, this is second edge, this is third, this is fourth, this is fifth, this is sixth, seventh, eighth, ninth, 10 11 12. So total 12 edges are there, right? And all this will add up to give you the value which is equal to 36, right? Now what we do, the sum of the all edges is 36, that means 12 times the edge, because you can see 12 edges are there, you can count it. 12 times A is equal to 36. So this will give you the value of A as equal to 36 by 12, which is equal to 3, right? So 3 centimeter, because 36 centimeter was, the unit is centimeter. So 3 centimeter is the edge of the cube which is calculated. Now what is asked into the question? If the sum of all edges of a cube is 36 centimeter, then the volume in centimeter cube of that cube is what? So the edge is calculated, so it's very easy to calculate the volume. To calculate the volume of a cube, you know, volume of a cube is what? Is equal to A cube, right? So A cube, that means A is calculated to you as 3 centimeter, right? A is calculated to you as 3 centimeter. So it will be 3 centimeter into 3 centimeter into 3 centimeter, right? So this will give you 3 into 3, 9, 9 into 3, 27. So 27 centimeter cube is the volume of this cube which we have calculated, right? I think you find all these few questions. We have solved 5 questions today in objective series. So I think all this will be helpful to you, And if you find it useful, you can like and subscribe. Thank you so much, students, for watching. Take care. Happy learning. Bye bye. See you. Be connected. Take care.